Now, Jeff, as we move forward, we need to keep in mind, well, we're going to move forward with cracking techniques. And as we move forward, we need to keep in mind that hashing a password is a one-way process. Now, you cannot take the hash and recreate the password. The mathematical algorithms used in this hashing algorithms are designed so that they cannot be reversed in any way, shape, or form.
Yeah, as we saw earlier, we can attempt to guess passwords, but we also stated that it is not as likely to bring a positive result, right?
Yeah, very true. Now, a dictionary attack has proven to be fairly successful, and it doesn't take as long because we can get lists of common passwords. You can take a list or dictionary file and run it through the hashing algorithms until you find a match with the hash that you had stolen. Now, this can be quite effective, and it does not take nearly as long as the other methods that we will look at. However, if your dictionary file does not contain the password, you will fail. Now, in my experience, 40 to 50% of the time, the dictionary files will succeed in cracking a few of the passwords at a company site. Now, so far, we've talked about guessing a password and using a dictionary attack. Now, Jeff, what can you tell us about brute force attacks?
Well, Laura, they're very brutish. A brute force attack is where we take every single possible combination available until we find the correct password and we just barrel through. And with a brute force attack, you will always succeed. However, it can take a considerable amount of time. Now, we can speed up this process a few different ways. First of all, we figure out what the password policy is and then perform brute force attacks that would fit that password policy. So in essence, we're not wasting our time on combinations that wouldn't even work within that organization. But more importantly, today's hackers are creating systems that have multiple GPUs, graphic processor units, that are then used to crack passwords. Now, even if you take your standard desktop system with a quad-core i7 processor, you could spend years trying to crack some of the passwords that we see used today. Now, as soon as you add even one GPU in combination with that processor, you really drastically reduce the amount of time that it takes to crack a password.
Oh, okay, that's interesting. Now, the URL listed here is an article on how a company took 25 AMD Radeon HD 9660 graphics cards and combined them together to be used as a hacking machine.
Wow.
Now, this is a complicated setup as it requires a virtual OpenCL cluster platform in combination with OCL Hashcat Plus software. But what hacker isn't educated in technology? This particular machine can try an outstanding 95 to the 8th combinations in just 5.5 hours when testing anti-LM passwords. Now, the same system can make about 63 billion guesses against a SHA-1. All in all, it is important for us to understand that the techniques, and more importantly, the power behind the techniques, have improved significantly, and we need to find ways to help mitigate these issues.
Yeah, that's right, Laura. In fact, we're going to look at some countermeasures in just a few minutes, but we need to finish talking about attacks first, right? There's just too much to talk about. Last but not least, we have the attack known as pre-computation, also known as a rainbow attack. You mentioned this before. Now, what we have done is taken every possible combination of an 8-character password and already computed that into a hash file, again, which is nothing more than just a simple database. So now we're cracking passwords. We take the hash that was stolen and compare it with all of them in this database to find a match. Now, we are not having to hash passwords in order to see if it matches. That's already been done for us. So it reduces the cracking time significantly.
Oh, okay, now moving on. Kane-Enable is one of those tools that can perform all these password cracking techniques under one roof. Notice that it can perform a dictionary attack, brute force attack, or a cryptanalysis attack utilizing the rainbow tables. We can easily understand how the use of rainbow tables reduces the amount of time that it takes to crack a password. A rainbow table also has a significant reduction in the amount of space required to store these hashed passwords. As an example, in a standard format, it can take as much as 417 terabytes of space to store every possible combination of 7-character passwords. Now, rainbow tables work differently, and you can store the exact same list of hashed passwords in about 80 gigabyte of storage space. Now, rainbow tables are used not only by hackers but also by forensic experts. I have often captured passwords for a colleague of mine who is involved in the forensic industry and has many terabytes of rainbow tables to look at. It usually only takes him a few days to send me the password that he has cracked using rainbow tables.
Okay, as we continue to look at password cracking, you'll recall that we have already seen a brute force attack and a dictionary attack that can be used to crack passwords. Now we're going to take a look at the most powerful password cracking method, and that is using rainbow tables to crack passwords. Now, rainbow tables take a tremendous amount of preparation on behalf of the hacker, but it is a one-time setup for each different type of password policy. Now, the point being, the long-term benefits are huge. It's the fastest way to crack passwords on average. Now, first thing we need to do, we need to add the LSA database or NTLM hashes. So we'll click the blue plus and import the passwords from the local system. Now, we can see that the admin account and the password hash that we have extracted is right there. And again, we can see that the LM hashes are all the same, meaning that the LM hash storage has been disabled, which is the default setting for Windows 7. Now, changing gears a little bit, from Windows Vista and Server 2008 till today, the default is to only utilize the NT hash that we see here. So let's discuss rainbow tables a little bit. You'll notice here I have a website in the URL. The URL is hashkiller.co.uk. Now we can see here there's an example of a rainbow table. You can have a list of passwords, as you can see here, along with the type of hash. Here is an MD5 hash for the password LISEK94. And down here, a SQL hash password down here at the bottom. There's a SHA1, SHA1 password, and so on. So this is a list of the last 50 decrypted passwords found. Now, generating a hash of a password utilizing a particular algorithm like MD5 will always return the exact same hash. So it's not possible that you would ever have a different hash from the exact same password. So let's get to it. What is a rainbow table? How does this actually work? Well, when we are creating a rainbow table, basically what we're doing is simply creating a list of the hashes of many different potential passwords. And then we're taking all these, we're putting all of them together into one table so they can be used by an application like Cain-N-Able or Loftcrack or John the Ripper. Now they all search through the table to find the matching hash. Now we provide the cracking tool such as Cain-N-Able and our hash of the password, and it looks for the identical hash in the table and then scrolls across to the next column and sees the clear text password associated with that hash. All right, you ready? Let's give this a try. Now, we first need to have a rainbow table, and we can demonstrate how you can create your own, but you can also purchase them or even download them from various hacker websites. Now, for us to create this, we can use a simple tool on the Windows operating system. It's called WinRTGen, which is installed with Cain-N-Able. The application is super easy to use. It's also available for the Linux OS. So from here, we select Add Table, and then we have various options. And first we choose which hashing algorithm we need to create a table for. Now, in our case, we are going to choose NTLM, that hash. Now here we will specify the minimum and maximum length of the password, and then of course we choose which character sets we want to create for this rainbow table. We can use all space, alpha characters, alpha with numeric characters, and of course every option available on your keyboard. Choose whatever you'd like. Now there is a large difference in the success rate depending on what you choose for your character set, obviously. Now notice the success probability here is only about 1.26% when using this character set. Now, if I use the lower alpha table, you'll notice that my success probably is much higher now, way higher, in fact, at 97%. So that is a much higher probability that this table will be able to find the password that you have extracted from the system. And that's because I'm using all of the alphabet, but it is just the lower alphabet. I'm not using numbers or uppercase in this situation. So in this case, I would want to be sure that the password is truly all lowercase letters. Now, when we start looking at what it takes to crack these passwords, and we think about downloading these rainbow tables from the internet, we find a couple of things. First of all, they're huge in size in order to contain 100% of the hashes for each different type of password policy. Now, many of them will be 50 to 60 gigabytes in size, and they will even not guarantee a 100% success rate. So let's take this, and we're going to go ahead and start generating the table. Now, click OK down here, and we will see the generating of the rainbow table start. Now, for this particular demonstration, we are not going to be able to wait for the rainbow table to finish creating because it will take many hours for this to finish, and I'm pretty sure you don't have the time to sit around and wait with me. So for that reason, we will use an online cracker. We will go back to the same site, and you can see here that we have the decryptor cracker, and we can choose NTLM decryptor. Now, one thing I need to mention, keep in mind, we're not actually decrypting anything. All we're just doing is finding a match of the hash and seeing what password originally created that hash. All right, so now let's return to Kane and export these hashes. We right-click and select Export, and we will save the file right to the desktop. Now, we need to open Notepad at this point to read the file, and here is the second hash, which is the NT hash. We will select this, we'll make a copy, and return to our website. Now at this website on the left side, we supply the hash, we scroll down and supply the CAPTCHA, and then click Submit. And in no time at all, we have, as you can see, cracked the password. Now granted, it was not a difficult password, but to find it was unknown for this website, and it took about 45 milliseconds. Now this is a great example of how rainbow tables work. They're very fast. The speed at which your password is cracked will depend again on how many computers are being used to process all of this data that you got to go through. Now the more power you throw at it, obviously the faster it's going to work. Now if we were doing the same thing on a standard PC, it may take considerably longer, but on average it is always faster than brute force or dictionary attacks, usually by less than half the amount of time. So one thing I do want to mention, again, it's important to note that when creating rainbow tables, they will be specific to different languages. So if we are cracking passwords in China, we will need different rainbow tables that we will use perhaps if we were in the Netherlands. Makes sense. So I want you to take note that it is not advisable to use websites like this to test your own passwords. They can monitor where individuals are connecting from, and frankly, it's possible that some of the information that you share here could very well be provided to a hacker. So be very careful. So Laura, I know you are, and I think everybody is very well aware that if a hacker has physical access to a computer, it's game over, right? But why is that? Well, because rather than create the plain text password from the hash one, a hacker can instead insert a new password into the Windows SAM database. Now you can boot any computer to a CD or floppy that contains a Linux operating system. Some of these bootable CDs are developed to help administrators recover systems where the user has lost their password, so there are legitimate reasons for having this type of an application. Once you have limited this to Linux distribution, many of them contain an application such as NT-Password, which allows you to insert a new password or blank password into the Windows SAM database. It does not matter if you're using Windows XP 7 or 8. The SAM database is the same on all of them, so this is a fairly easy way to gain full access to the system.
Exactly. Now, in my experience, it is better to replace the previous password with an asterisk, which is a blank password, rather than trying to place a new password string in the database file. Also, when you restart the system, do not run the check disk operation, as it could cause the attack to fail. Now, a countermeasure, we like those, right?
We do.
Such as disk encryption can render this attack unusable. We will look at that in greater detail later, but first, let's look at password sniffing.
Password sniffing is another method of capturing passwords, but it requires some form of access between the user and the application that it is performing the authentication. So this can take on various forms that can be either technical or physical. Social engineering is a means of sniffing passwords by simply listening to individuals ask each other questions. But most likely, you're talking about a virus that is going to install a keylogger and log keystrokes to sniff those passwords, or some type of a man-in-the-middle attack that is going to steal credentials between the client and the server. Now, encrypted sessions make this a lot more difficult, but there are methods such as ARP cache poisoning that will allow us to capture passwords even with encrypted sessions.
Right. And Microsoft Windows operating systems have different types of authentication methods. Keep in mind that the hashing algorithms we discussed before are not the same thing as the authentication protocols. Now, what we are discussing here is how authentication works with different types of protocols.
Exactly. So let's get started by talking about LM authentication. With the LM authentication protocol, the authenticating server will convert the user's password to all uppercase before hashing and storing it, just like the hashing algorithm. The user's workstation will then convert the password submitted by the user to all uppercase. The workstation then pads that password with extra nulls to make it up to 21 bytes. Now, if you recall, the LM password is a maximum of 14 characters, and if it's less than 14 characters, it will null fill until it reaches 14 characters. Now that is the hashing component. So now that the workstation has a 21 byte password, it will divide that by 3 and have 3 separate 7-byte groups and then converts each of them into a 64-bit encryption key. Now the security system will then encrypt the nonce, which is a random set of data provided by the server. It encrypts the nonce 3 times, 1 by each of the newly created encryption keys, and then it returns them to the server. The server will then perform the exact same action on the locally stored password using the all uppercase LAN manager version, and then compares the results to authenticate the user. Easy.
Okay. Yep. The NTLM authentication protocol is fairly simple. The client will request authentication and then the authentication server will respond with an 8-byte challenge. This challenge is simply a random piece of data. The client will encrypt the challenge along with the user's password, which they entered into the password field. In this early version, both the LM hash and the NT hash are used. So the client will return both 24-byte results to the server. The server performs the same action and then verifies the password for authentication. Now, Jeff, is there a newer version of NTLM?
Yeah, and it's got a fancy name. It's NTLM v2.
Okay.
Yeah, it's a challenge response authentication protocol. It's similar to the other versions that we've looked at. However, this version includes a challenge from the client as well as the server, adding yet another layer of security. So that's important. The client is going to receive an 8-byte server challenge, which you described, in which it will respond with 2 16-byte responses. The response is the HMAC MD5 hash of the server challenge, a randomly generated client challenge, and an HMAC MD5 hash of the user's password and other identifying information. In order for the server to verify the response, it must receive as part of the response the client challenge. For this to happen, the 8-byte client challenge is appended to the 16-byte response, making up a 24-byte package, which is consistent with the other versions discussed already. Now, the second response set by the client uses a variable length client challenge that includes 4 separate items: the current time in NT format, an 8-byte random value, the domain name, and some additional standard formatting. This response also has to include a copy of the client challenge, and it is therefore a variable length. So, this authentication protocol has some additional detail that makes it more secure, along with 2 separate responses.
Now, thanks, Jeff. And there is one more authentication method we want to discuss. Kerberos is the authentication method used by today's Active Directory domains and has been used since Windows Server 2000. The client needs to authenticate itself to the authentication server. Then the authentication server forwards the username to a key distribution center. The key distribution center will issue a ticket granting ticket, which is time-stamped and encrypted using the user's password. It will then return the encrypted result to the user's workstation. This is not done frequently because the ticket will last for some time. Now, when it expires, most of the time the ticket is renewed quietly in the background by the user's session manager as long as they are still logged in. Any system or node in the network that the user or client needs to communicate with can do so with the ticket they have been issued. The workstation will provide that ticket upon request as a user communicates with these different nodes. Because Kerberos takes the authentication mechanism off of the local system, it adds security.
Okay, and just to add to that, it's important to keep in mind that even though Kerberos is a more secure authentication mechanism than the other versions we have seen, it is still susceptible to
Mm.
attacks. So there is an older tool that still works against Kerberos as long as you have access to the network where the authentication is occurring. You can also use a tool called KerbSniff to capture the authentication traffic and output it to a file. Now at this stage we can simply pass the hash and log in with that, or we can use the second half of this tool called KerbCrack, which allows us to brute force or dictionary attack this password. Now I prefer personally to use some of the other methods of cracking passwords, but this can and will work as needed. All right, this particular demonstration is a very dangerous one because there are multiple zero-day attacks associated with this. So we're going to demonstrate only the attacks that have countermeasures. However, the only countermeasure for this attack is a good antivirus solution. Now, at this point, we have taken this attack and adapted it to bypass these countermeasures, but we are not going to demonstrate that to you. We're going to take a little time and go right to the point. So I keep in mind that when you log into your Windows operating system, you're going to use your username and password, and it's stored in memory. And we know already that the LSA database stores all the local user accounts, and a hashed function and the Active Directory accounts are stored in an MD5 hash on the Active Directory server. So what all this means is that an Active Directory user account is not stored locally on the system. But when you log into the machine with that Active Directory account, the password will be in memory, so it can be accessible. Now, due to the weakness in the Windows architecture, we can exploit the LSA process and dump the passwords from it. So, as an example, if we go to the Task Manager and then select the Process tab, we can then find the LSAS-exe process running, and this process has all the passwords of the accounts logged into the system. Now let's remember that these passwords in memory, are not hashed passwords in a clear text. So in order to gain access to those passwords, we must first create a dump file for them. So we are going to right-click the process and choose Create Dump File. We're going to wait just a second, and now we can see the location of our dump file, which we will need to copy. So let's open the Run box, paste the link, press Enter, and here is the folder that contains the dump file. Now we can close the Task Manager at this point. All right, now at this stage we need a tool that can actually read the dump file, and this is where the hack comes in. A tool like Mimikatz can read that dumped file. Mimikatz does have two different versions, as you would expect, one for 64-bit OSs and one for 32-bit. And as you would expect, it depends upon your victim machine as to which version you will actually use. Now, generally, a hacker would create a script that would automate the creation of the dump file and transfer that dumped file to an FTP or other location externally that they have easy access to. For this demonstration, we are going to copy that dumped file to the Mimikatz directory. We are using the 64-bit machine, so that is where we will place this. And I will open Mimikatz now with admin privileges, and now we need to escalate the privileges of Mimikatz to debug rights. In order to do this, we simply type privilege debug and press enter. We can see now that we have the debug privilege. We can see this because of the OK message. Any other response would end up in a failure as we continue. Now, the next command is the one that allows us to actually steal the passwords. We simply enter SEKUR-LSA log on passwords and press enter. Now let's see what this hacking tool has provided for us. Now you can see here the user account, computer name, and if this computer was joined to a domain, we would see here the domain name. We also have the SID, the SID for the account in use currently, and then we scroll down and we see here the username, domain, and password in clear text of the accounts currently logged in. Everything we need. Now notice that we have multiple entries for the same account, and that is due to different types of authentication methods in use. You can see here at the bottom the Kerberos entry. It's important to take note here that this tool cannot only reveal the passwords of the account or accounts that are currently logged in, it can also reveal any previously logged in users. Maybe it was a day ago, maybe it was longer. It will all depend on whether or not the area of memory was needed, or in this case, if the system was restarted. So if you want to see more than just the currently logged in user, we have to slightly change our command, but it's pretty easy. We simply need to add after the previous command the word full, and then press enter. Now, in this demo, we did not have any other users logged in previously, so there is nothing else listed here. But if we had, then obviously right here they would be listed. It is also important to take note that if we happen to dump the password file of a terminal server, well, at that point we would be able to see the passwords for every user that has used the terminal server in the recent history. Now, this is a very sweet attack. Keep in mind that if we can manipulate the system to dump the terminal server passwords remotely, what does that mean? It means now we have taken ownership of the entire system, because you can bet that the individuals using a terminal server, pretty good chance they're administrators. So this is a very dangerous attack, and it is one that you need to understand completely. So this is my advice to you. Spend some time playing with this on your own in an isolated environment, as obviously you don't want to expose your production environment to any unknown threat. Also, another point, make sure you have a good antivirus solution that can minimize this, but also consider utilizing a standard user account on your terminal servers rather than an administrative account, as this will help minimize the impact of stolen passwords.